Alright, so let's say we have a ladder, and it's the wall is kind of slippery, and the floor is also slippery, so suddenly it starts to come down. Maybe I should make it more exciting and make some person beyond it. Okay, okay, let's just simplify it. So let's just say we have a ladder that's about 9 feet. And then the question is, if the ladder is sliding down the wall, at, say, 6 feet per second, when it is say 4 feet from the ground, how fast is the end, the opposite end sliding on the ground at that time. So you get the point, right? It's sliding down at some point when this is like 4, and also it's going down at 6 feet per second at the time. Then the question is, how fast is this moving? All right. So I have 9 here. So the simplified picture should be 9 here. That's always fixed. But these two sides are changing, right? So let's put an X here, and that's Y. And because we really want to see the relationship between these two, we need to assign variables here. Let's try to translate each of these numbers. So 6 feet per second is going down. So how do you write that number?
-6.
It's the rate of change. It's -6. So it's dy dt is -6. And then when it is 4 feet from the ground, but then look, this has the when, right? So this 4 feet should be considered later, okay? Now what is it trying to ask for? How fast is this opposite end sliding on the ground? So we're looking at the speed dx dt, right? So the question is, what is dx dt? And then when what?
When y equals
Y
0.
equals 4.
So this picture, this condition, this question, that's everything. This complicated word problem is this picture, this condition, this question, that's it. Now, we have to come up with the relationship from the picture. What's the relationship between x and y?
Pythagorean theorem.
Pythagorean theorem. This is the case when you have just a single right triangle. In that case, Pythagorean theorem. This is considered like one of the easier ones. You just have to use the Pythagorean theorem. That's it, okay? So x squared plus y squared is 9 squared. That's the relationship. Okay, so now I have everything. I have the relationship, the rate of change of one variable, and the condition, and then the question. So now we start doing the computation. How do you find the answer from here? you differentiate the relation, right? So differentiate the relation. And that gives you x squared differentiates to
2x
2x dx dt. Y squared differentiates to
2y dy dt.
2y dy dt. 9 squared differentiates to
0.
yes, 0. This is a constant. Or if you prefer, it's 2 times 9 times d of 9 with respect to t. But what's the derivative of 9 with respect to t?
0.
0. So either way, it's 0. Okay, so that's what we have. Then you plug these numbers in, right? Since I've already differentiated, now we can involve y equal to 4 without any problem, okay? So you should be using y equals 4 before you do the differentiation. Okay, so y equals 4 should be plugged in here. dy dt should be here, so you have 2x times dx dt plus 2 times 4 times negative 6, which is negative 48. So dx dt is 48, and then, well, 2x times this is 48, but then you divide both sides by 2x, so that you get dx dt equals to 24 over x, which is not what you want yet. Right? By the way, this is really y equals to 4. We know we need a number here because we have enough information to determine dx dt. So we have to resolve that x somehow. What do we do?
So if you plug y equals 4 into
Y equals to 4 should be plugged back in here to figure out what x is, right? So you say x squared plus y equals to 4 equals 9 squared. So 81 minus 16
65.
is x squared, so x is square root of 65. And that goes in here to finish off the problem as 24 over square root. What's the correct unit here? X is a unit of what? X is measured in feet. Time is measured in seconds. So that's how you solve this.
Way easier not to time.